the top before the title of the review, I've got a few things because I wanted to show you what you're going to be given on the test, okay? So this is going to be on the top of your scratch paper / formula chart that you get. So you're going to be given distance formula with the formula this way with x2 minus x1, y2 minus y1, okay, or with using Pythagorean theorem with creating the triangle. So the distance information, midpoint formula with a picture to help remind you the midpoint is the middle, okay, and you can count your full vertical and horizontal distance, okay, and you can count halfway to find your midpoint. Okay, so formula and picture for both distance and midpoint, and a reminder about the angle addition, okay? That angle ABD plus DBC would be ABC, okay? That you would add those two smaller angles together to get the whole angle, right? Do y'all remember that?
Yeah.
Okay, so those are the reminders. That's what's on the formula chart / scratch paper you're going to get. So you don't have to have those formulas memorized, okay? I'm just going to start with the front just so we can knock out all this vocabulary, because if you don't know the vocabulary, you're going to miss a lot of things, not because the math is hard, just because you didn't understand maybe what it was asking. Okay, so in number 1 here, and there is vocabulary on the test. There's multiple questions that are just vocab matching. Okay, do you know what these terms mean? So if you are still struggling with these, you need to be studying the vocab tonight. Okay, make yourself some flashcards, actual index card flashcards, or you can go online and do digital flashcards. Quizlet, if you've never used Quizlet, that's a good website to make digital flashcards. That's a good way to study vocab. Okay, they even like make games out of it. All right, so a flat surface made up of points that extend in all directions, and it must have at least 3 points, but not on the same line. That is a plane. Very good. Okay, remember when we depict a plane, like with a picture, it normally is shown as like a parallelogram, but a plane is just a flat surface that extends forever in all directions. Okay, to name the plane, we do need to use at least 3. We use 3 letters to name a plane, and they cannot all 3 be collinear. They have to, one of them has to not be on the same line as the other 2. All right, B, part of a line. It has a starting point and extends forever in one direction. Array, so 1 point, 1 arrow. 1 point, 1 arrow, that's array. If you want to draw a picture, okay? 2 rays that have the same endpoint and extend in opposite directions. This one might be tougher just to grasp immediately. And think about this when you're doing matching with vocab too. You can skip it and come back to it if there's one you're unsure of. Because some of y'all may visualize part of this correctly, but not quite all of it. So I'm actually going to come back to that one with you because I want to explain some things on it. Okay, so D says something made up of 2 or more points and it extends forever in 2 directions. Okay. What is that? Made up of 2, it has 2 or more points. Yeah, it goes on forever in 2 directions. That really, technically, that should say opposite directions because it's not 2 random directions. There's no turn. It's 2 opposite directions. Okay, and that's going to be your line. And it's actually made up of infinitely many points. But when they say 2, it means there's going to be like 2 or more labeled on there. Because to name the line, we need 2 points to name the line. Okay, 2 angles that are next to each other and share a common side. Yes, if they are next to each other and share, oops, get out of here. That would be like this. They're two angles next to each other like this. These two angles here and here. Okay, they're next to each other. They share this common side. They don't have to be congruent or the same side. They just are next to each other. That's adjacent. Adjacent angles, technically. A location that has no sides and no shape. It's just a location. A point. A point is simply a location. Okay. Part of a line, it has a definite beginning and ending. So two endpoints. Yes, if it has no arrows, it has an endpoint on both sides, that's a line segment, or you could just say segment. Any two angles whose sum is 180. Supplementary angles add to 180. Remember the memory tricks I kind of tried to help you with supplementary and complementary because people get those confused. If you do a 180, that's turning around, right? Half a circle. And we said, oh, if you take supplements are like, you know, for your health, like your health will do a 180. Take supplement. Okay, located in the middle of a segment, it separates the segment into two equal parts. Yeah, it's in the middle. It is the midpoint. Two angles across from each other at an intersection. And they are always congruent. Vertical angles, good. Okay, vertical angles would look something like, you have an intersection, that would be these two across from each other. Right, two segments that have the same length. Okay, just same size, same measure. What's the geometric term for that? It could be two segments that have the same length. It could be two angles that have the same measure. It's just two figures that are the same size, the same measure. What's that word? Congruent. Congruent. They're equal measure. Okay, points that lie on the same line. Good, it's line, it's linear. Same, when we see same, that's the co. Okay, so if they're together on the same line, they are collinear. If they are together on the same plane, they are coplanar. Any two angles whose sum is 90. So supplementary was 180. What's 90? Complementary. And remember the memory trick? I said to compliment someone is the right thing to do. So complementary means a right angle, 90 degrees. So complementary 90, supplementary 180. Okay, and then two angles that are adjacent and supplementary. Yeah, so they're adjacent, meaning they're next to each other, and they're supplementary, meaning they add to 180. So they form a straight line. That would look something like this. These two angles, okay, they're adjacent, they're next to each other, they share a side, but they also form a straight line, which is 180 degrees. So they form a line, they are a linear pair, line linear. Now the one that I skipped, okay, some of you may have gotten it, some of you may have not. Okay, the reason I skipped it is because I actually don't like that it says opposite direction. I'm actually going to fix that. Okay, because two rays that have the same endpoint they just have to extend in different directions. I'm going to change that to different directions. Because opposite is like what a line, these extend in opposite direction. That's what makes it a line. Okay, just different directions. If I have a ray here and another ray with the same endpoint going in a different direction, what have I created? This right here? An angle. Okay, these aren't going in opposite directions, they're going in different directions. Okay, it creates an angle. Okay, they can go in opposite directions, and that would make a straight angle. Okay, but if they're just going in different two rays with a common endpoint, okay, they're going in different directions, that's an angle. Okay, so if you missed any of those, just get those fixed. Okay, any questions about any of that vocabulary? Okay, let's look at this at the bottom of this page, and we'll be done with the first page. It says, use the plane below to answer 2 and 3. Okay, so remember we said a plane is normally depicted with a parallelogram like this. So we're visualizing this flat surface. Okay, we imagine that it goes on forever in all directions. Okay, but we've got this flat surface, and you've got these blue lines on it intersecting. Okay, and then this line R here, is coming down through it. It's like puncturing it, and then that's why it's dashed there, because that's like underneath, and then it keeps going down forever. So imagine like your pencil poking through your flat piece of paper or something like that, if that helps you visualize it. Okay, so you've got this plane, and you've got this line poking through it, and then you've got these other lines laying on top of it. So name all the points that are coplanar with point C. So C is here. It's on this blue parallelogram plane. So what other points are on this plane? E. What else? What else? E. I don't know why that just moved. Okay. Fix that. For E, F, D. What else? B. B. Q. Now Q is not a point, is it? See how Q is an italicized or cursive lowercase letter? That's there to name this line. Okay, a lowercase letter does not name a point. Okay, remember points are named with capital print letters. Okay, same thing. P is not a point here. It's here to name this line. The capital cursive R, that's naming the plane. Remember, the cursive letters, if they're lowercase, they're naming a line. If they're uppercase, they're naming a plane. So that P, R, and Q are not points. A is a point, but is it on that plane? No, it's not. Okay, and then R is also not a point. It's naming this line. Okay, so that's it. Those are the other 4 points that are on this plane R. Okay, now it says to name the plane using one letter. I just said it, plane R, because it's the capital cursive letter that names the plane. Okay, so you say the word plane, and then the capital cursive letter. Okay, the other way to name a plane, if there's not a capital cursive letter, is with any 3 points on it that are not all collinear. So I could also call this plane CFE, or CFD, or BFE, or BFD, several different combinations. I could have picked 3 points that are on the plane that aren't all 3 on the same line, and I would have used the print capital letters, but it did say 1 letter, so I know it wanted that capital cursive letter. We feel okay about that? Okay, I'm just going to keep going in order then. That'll make these videos easier. And then if there's questions that we don't get to, remember in this class period, I will in another, and all the videos will be posted. So you'll be able to go and check them and ask questions. Yeah, just take a pass with you. All right, so on number 4, they want us to name the angle in 4 different ways. Okay, so remember naming angles, we can use one letter if there is only one angle at that vertex. What is the vertex here? The vertex is a point, and we name points with letters. So what is the vertex here? Q. So this point, it's the turning point of the angle. It's the corner. Okay, that's the vertex. So Q is the vertex, and there's no other angle here but the one pictured, right? Because these are both rays. They don't intersect. They don't extend. So it's not creating any other angles. So I actually can just say angle Q. In this case, that's okay. Now I heard somebody say 4. Because it's marked with a number, I can also call this angle 4. Now, if there were other angles and I wasn't allowed to just say angle Q, I would have to use 3 letters. And remember, if you're going to use 3 letters, you have to have the vertex as the middle letter. Okay, connect the dots. Okay, so I could go PQR, and that would trace this angle. Or in reverse, I could go RQP. Okay, but Q has to be in the middle. Is everybody good with naming that angle? Okay. In number 5, it tells us, remember this little M in front of the angle symbol means measure. So it says solve for the measure of angle KLM. So first I'm going to trace that. KLM. So that's this big angle. That's what they want to know. They want to know the entire measure of that blue angle. They tell us that KLN, so KLN, that's this green one here, is 67 degrees. And that NLM is 48 degrees. So I trace NLM, so that's this purple one here, is 48 degrees. So what am I going to do to find the big blue angle? Yeah, I'm just going to add them. This is what I said at the very beginning. I reminded you this is going to be on the formula chart. This is angle addition. The 2 smaller angles have to add together to equal the big angle. Okay, so that's all we're doing here. So the 67 plus the 48 will give us this whole big angle that we're trying to find. So 67 plus 48. $115. Okay, and it is an angle, so we will put the degree. That's our unit. All right, here, similar problem. And actually, I'm going to use the colors I used in our notes. We said red plus blue equals purple is what we did in our notes. So we did the smaller angle. Okay, so this one gives us, it says solve for PQS. So PQS is one of the smaller angles. That's what we want to know. And then they tell us the whole big thing, PQR, whole kit and caboodle here, the big part is 107. And SQR, so that's this other small one here, is 59. So what do I do with those? Well, if I know the 2 smaller ones, I added them. This time I know the big one. Yeah, so I'm going to subtract this time. I have 107 is the total, take away the 59 that one of them used to see what's left for the other angle. So 107 minus 59 is 48. So 48 degrees left for that blue angle. Does that make sense? So the angle addition postulate, you may have to add, you may have to subtract. You have to know how to name the angles so you know which ones they're telling you, right? That's why naming angles is so important. You can't answer these if you don't know what these angle names are. Okay, so here's one, angle addition again, except this time it's with the algebraic expressions instead of just angle measures. So it tells us, given the measure of angle ADC, so ADC, that's the big one, right? If I connect that, and I meant to do that in purple. So A to D to C, that's the whole big thing, isn't it? Is 65. Okay, and then they want us to find X and the measure of BDC. Well, B to D to C, that's this one here. So they want us to find that little blue one, okay, down here. Well, I know that those two angles together should add to the whole big angle, shouldn't they? So the red angle plus the blue angle should equal the purple angle. Y'all remember doing this in our notes? Okay, so now we have to do algebra. Okay, we're going to combine like terms on this side over here. So we've got 3x's, and we've got 7 and 19, so that's a positive 26. And then you're ready to start moving terms across the equation. So I'm going to move the 26. To move things, you do the opposite. So since it was a plus 26, I'm subtracting. And what I do to one side, I do to the other to keep it balanced. Okay, so 65 minus 26 is 39. I've got just the 3x left over here. And then to get rid of that coefficient of 3, that's 3 times x, so the opposite is divide. So I'm going to divide out the 3. 39 divided by 3 is 13. So one of the questions is asking us to solve for x, said find x. So we did that. But then they also ask us to find the measure of angle BDC. That's the blue angle. So then I have to go back and plug that x into the blue angle. So then 2 times 13 plus 19 would come out to 45. So that's the measure of angle BDC. So that was a 2-part question. And you are going to have some on your test like that, where there's 2 things that you have to answer. So make sure you're reading carefully. Okay, this is another angle addition, except this one, what type of angle is this that it forms across the bottom? A 180, it's a straight angle. This is a linear pair, right? Adjacent angles that add to 180, they form a straight line. So it's angle addition again, but it's not going to add to some random total that they tell us. It's going to add to 180. Okay, so I'm going to label what they tell us. They tell us DAC, that's the one I outlined in blue, is x plus 60. And they tell us CAB, that's the one I outlined in red, is 2x minus 30. And y'all told me together these form a straight line, so that's 180 degrees. So I'm going to set this up very similarly. The red plus the blue equals the purple, but this time the purple we have to know is 180. Yes. So I'm going to combine like terms again. So I've got 3x's again. Then I've got 60 minus 30, so I've got plus 30. So then I'm going to move the 30 by subtracting. And then divide by the 3 again. So this time, x is 50. Now this time it didn't ask me to solve for x, did it? It only asked me to find the measure of CAB, which is the red one, right? So I'm going to take that 50 and plug it in for x in the red angle. So that's 70 degrees. Now, had they asked for the other one, what would the other one be? Because I know they have to add to 180 together. Yeah, if this is 70, that has to be 110. Okay, so you could have answered that as well. How would you feel about those? Okay. All right, let's go ahead and flip that page then. Okay, now this one's getting into some more complex intersections. It's not just two angles side by side. We've got a few different angles here, and we've got to understand the markings because it tells us that this tiny little angle's 9 degrees. It tells us that this one is 90 degrees, even though it doesn't say 90. How do I know that's 90? Yeah, that right angle marking there. Okay, so we've got a 90-degree angle there, a 9-degree angle, a 42-degree angle, and we're looking for x. But what do we know about all 4 of these angles together? They're all one. Yeah, that's a straight line, isn't it? The straight line's how many degrees? 180. 180. So all of these together, it doesn't matter how many it's broken up into, they all together need to add to 180, right? So if you need to write it out like this, you can. You have the 42, the x, the 90, and the 9. Okay, all of that together should add to 180. So then you just add up what you know. So 90, 9, and 42 is 141. So some of you won't write it out as an equation like this. You would just add those off to the side and then subtract it from 180. But you're doing the algebra. You may not write it out as an equation like this, but that's still algebra that you're doing. So when you take away, they have to add to 180 and you've used 141, so there's 39 degrees left for that angle x. Okay, yeah. Yeah. Okay, I'm gonna stop. We're not gonna stop necessarily, but I'm gonna stop this video here because that's the end of like that type of question, then it gets into midpoint and distance. So I'll make a separate video going over the next group of questions. So let me stop this video here.